How's it going, guys? Today in this video, we're going to be going over the Module 13 test review. So let's go ahead and get started. Number one, we're told to analyze these all these parent functions. The first one we have is a growth function. Then we have a decay. And then we have a base E parent function. So the domain for all three of them is going to be all real numbers, from negative infinity to positive infinity. The range for all three of them as well is going to be y is greater than 0. The k value for each of these parent functions is 0. The a is positive. So the range for all three of them is y is greater than 0. The y-intercepts always happen when x is 1. And when x is 1 for each of these functions, anything raised to the 0 power is always 1. So the y-intercept for all three of these is 0, 1. You plug in 0 for x, and they each work out to be 1. The x-intercepts for all three of these, we don't have an x-intercept, and that's because x-intercepts happen when y is 0. And we said that we have a asymptote, or we're going to say we have an asymptote at y equals 0, which is at our k value. So if we have an asymptote at y equals 0, that means we can't have an x-intercept because the whole x-intercept is your asymptote, and you cannot cross your asymptote. End behaviors. So for the first one, well, let's actually go as x goes to infinity. F of x is going to infinity as well. So rewrite that. We don't have much room. X going to infinity. F of x is going to infinity as well. They don't really give us a lot of room. And then the other end behavior is x is going to negative infinity. F of x is going to 0. So the other one is x is going to negative infinity. F of x is going to 0. For the decay function, as x goes to infinity, f of x is going to be going to 0, and as x goes to negative infinity, f of x is going to infinity. And lastly, for the base function of e, that's going to be as x goes to infinity, f of x goes to infinity, and as x goes to negative infinity, f of x goes to 0. It's the exact same thing as a growth function, since a base E exponential function is still a growth function. So they're both the exact same thing. Number 2, we're asked to list the transformation for each parent function. So for the first one, for 4 times 2 to the x minus 2, the transformations there is we have a vertical stretch because of that a value of 4. And we're being shifted to the right by 2 because of our h value of positive 2. Remember, it's x minus h. For the second one, we have a negative 1 for our a value. So we have a reflection, or we reflect over the x-axis. And we also have a plus 5. Our k is 5. So we shift up by 5. And lastly, for the last one, we have an a value of 1/4. So it's a vertical compression. And then we have an h value of negative 1, since it's raised to the x minus h. So it's shifted to the left by 1. And then we have a negative 3 for our k value. So we shift down by 3. So now we need to fill out our reference points. So for f of x equals b to the x, and this is when b is greater than 1, so it's a growth function. Our reference points will be 0, 1, and 1b. And our reference points will be h, comma, a plus k. And for 1b, that's h plus 1, ab plus k. our asymptote, and that's going to be for all of these. For the parent function, it's always y equals 0, since our k will be 0 in our parent function, and our transformed asymptote will be y equals k. And that'll be for all three base functions of E, growth functions, and decay functions. All right, so for B now, transformations of f of x equals b to the x, when b is between 0 and 1, or in other words, it's a decay function. Our reference points here are 0, 1, and negative 1, 1 over b. So for the transform point of 0, 1, that's going to be h, a plus k. For negative 1, 1 over b, that's h minus 1, and a over b plus k. And finally, transformations for the base function of e. Our reference points are 0, 1, and 1 comma e. For 0, 1, we get h, a plus k. And for 1e, we get h plus 1, ae plus k. So something I want to say is that for all these transform reference points, you don't have to have them memorized, because you can always plug it into, or plug in the reference points into x plus h, ay plus k, and you get the same thing. So plug in your parent function reference points into your transformation rule for all three of these, and you'll always get your transformed reference point if you do. So you don't have to have it memorized if you don't want to. You can just memorize the transformation rule, which you need to have memorized, and get your transform points from that. So now we're going to do a few graphing problems. So for these, I'm going to do only one of these for each type of function. So I'm going to do one of the transformation, one of these transformed exponential growth functions, one transformed decay function, and one transformed exponential of e function, or base exponential e function. So for number 4, our domain here is negative infinity to positive infinity. The domain will always be all real numbers, or from negative infinity to positive infinity for all exponential functions. Our range is going to be y is, well, before we do the range, actually, let's take a step back and actually fill out our a, b, h, and k. Our a is negative 3, our b is our base of 2, our h is 2, and our k is 2. We should have started with that to begin with. I don't know why I jumped to the domain, but we should break down the function first into a, b, h, and k, which we just did, and then we're going to go into solving all this out. So like I said before, the domain is all real numbers. And now before we find the range, just find our asymptote. That's always y equals k. So in this problem, it's y equals 2. And now for our range is going to be, it's going to depend on the a value and the k value. If our a is positive, that means we're above the asymptote, and if our a is negative, that means we reflect it over the the x-axis, so we're below the asymptote. So our a here is negative, so that means we're below the asymptote. So that means our function of y is going to be less than our asymptote of 2. So that right there is our range. Our function of y is less than our asymptote at 2, and that's because we have a negative a value, so we're reflected over the x-axis, so we're below the asymptote. So now let's transform our two reference points, 0, 1, and 1b. So before we do that, I want to write out what our transformation rule is going to be, because we didn't really give you space for it, but we really should have. So our transformation rule, remember that's x plus h. So in this problem, it's x plus 2, comma ay plus k. So negative 3 y plus 2. That's our transformation rule for number 4. And we're going to plug in 0, 1, and 1b into these functions, or into this transformation rule, to get our transform points. You could put into the transformation points that we learned in the last slide, but I don't like doing that. I prefer putting it into the transformation rule and getting it out that way. So we have the point 0, 1. I put that into the transformation rule. 0 plus 2 gives us 2. And we plug in 1 for y. We get negative 3 times 1, which is negative 3, plus 2, which is negative 1. So 0, 1 transforms into 2, negative 1. You plug that reference point into there. And now for 1b, That's the same thing as 1, comma 2, since our b value is 2. So if that 1, 2 is the point we're transforming, that's what we're putting into the transformation rule to get our new transformed point. So when we plug in 1, 2 into the transformation rule, 1 plus 2 is 3. That's when x is equal to 1. And when y is equal to 2, we get negative 6 plus 2, or just negative 4. So those are our two new transform points. So we're going to go ahead and graph them, or sorry, we're going to plot this whole function. The first thing we should always do is plot our asymptote, or draw our asymptote. That's at y equals 2. So that'll be right about there. And our 2 points, 2, negative 1 will be right about there. And 3, negative 4, right around there. And since our b value is greater than 1, that means we're a growth function, so I know the shape of this function will be starting near the asymptote and growing away from it. Growth functions always start near the asymptote. That's an ugly graph. When we start near the asymptote, and then we grow away from it. So it's going to look something like that, more or less. Number 5, I'll leave that for you guys to do on your own. We do put the completed keys up on Canvas, so double check your answer there. On the next slide, we have 6 and 7. I did a b value of 2 in the last slide, so let's do a b value of 10, or 1 over 10 on this one. So we're going to do the same thing. We're going to fill out our a, b, h, and k first. Our a value here, that's that negative 1 in the front. Our b is the whole fraction 1 over 10. It's not just 10, it's 1 over 10. Our h is negative 2, and our k is 7. So our domain, it's still an exponential function. So in interval notation, it's negative infinity to positive infinity. Before we find the range, let's go ahead and find our asymptote. That's always at y equals k. So in this problem, y equals 7. Now for our range, we're going to look at the a value and we're going to look at the k value. Our a is negative. That means we reflect it over the x-intercept, or the x-axis. So we're below the asymptote now. So that means our function of y is less than or below the asymptote at 7. So that's our range. And now we're going to do the same thing we did before. We're going to write out our transformation rule. So it's x plus h, so x minus 2. Then our a value of negative 1. Or yeah, negative 1 times y, so it's ay plus k. So just write it as negative y plus our k value of 7. So that's our transformation rule. So for 0, 1, we'll put that into our transformation rule. 0 minus 2 is negative 2. And then 1, we put that into y, you get negative 1 plus 7 is 6. So that's our transform point for 0, 1. And now we're going to do the same thing for negative 1, comma 1 over b. But we need to figure out what 1 over b is first. So negative 1, comma 1 over b is 1 all over 1 over 10. Since our b value is 1/10, and since we have a 1 all over a fraction, that's going to flip and just give us negative 1 comma 10. 1 over 10 is the same thing as 10. So that's the point we're going to put into our transformation rule to figure out our transform point. So negative 1/10. We plug in negative 1 for x. We get negative 1 minus 2, which is negative 3. And then we plug in 10 for y. We get negative 10 plus 7, or just negative 3. So that's our 2 points right here. And we have our asymptote. So we can go ahead and graph our function. So we have an asymptote at y equals 7. So right about there. And then we have 2 transform points, negative 1, positive 10, right around there. And negative 3. Oh, sorry, not negative 1/10. That's our original point. It's negative 2, positive 6. So right there. And then negative 3, negative 3. Negative 3, negative 3, right about there. So we know it's a decay function since our b is less than 1 but greater than 0. So it's a decay function, so we know we're starting away from the asymptote and growing into it or decaying into the asymptote. So our function will look something like that. And that's number 7. Keep on going. And here we have number 8. We'll go with that one. So here, our A value is negative 1/2 or negative 0.5, whatever you want to say. Our B is just E. Our H is 2, and our K is negative 2. So our transformations, or really, I'm just going to make our transformation rule. It's x plus h, so x plus 2. And then ay plus k. So negative 1/2 times y is just negative y over 2 plus k, so minus 2. Our asymptote is at y equals k, so y equals negative 2. Our first reference point is going to come from 0, 1. And we plug that into the function, we get 2, and negative 1/2 minus 2 is negative 2.5. And then the second reference point, that's coming from our 1, comma e. You plug that in, you get 3, comma negative e over 2 minus 2. And that's going to give you approximately 3, comma negative 3.4. That's approximately what negative e over 2 minus 2 is. Our domain, it's still an exponential function, so it's all real numbers. So in interval form, negative infinity to positive infinity. Our range depends on our a value and our k value. Our a is negative, so the function is below the asymptote. So our y value is less than our asymptote of negative 2. So we have everything we need to actually graph our function. So let's go ahead and do that. Our asymptote is at y equals negative 2. So right there, in our 2 points, we have 2, negative 2.5. So right there, and then 3, negative 3.4. So right about there. And every exponential function with a base of e is still a growth function. So that means we grow away from the asymptote, or we start near the asymptote and grow away from it. So that's what our function is going to look like. Number 9, I'll leave for you guys to do on your own. The completed key, like I said before, is going to be on Canvas, so it should be there if you want to double check your work. All right, let's go on to number 10. So same as before, I'll do 1 exponential growth, 1 exponential decay, and 1 exponential with a base of e for these types of problems. So let's go with number 10. So we're saying let b equals 2, so we know our b value. Our asymptote, looking at the graph, is y equals negative 5 over 2. So that means our k is negative 5 over 2. Our asymptote is always y equals k. Our first reference point, that's going to come from the point 0, 1. So the point 0, 1 compared to the point 1, comma b, 0, 1 has a smaller x value. So we're going to pick the point here with the smaller x value. So that's going to be the 3, negative 1. And that's going to be our first reference point. So our h value, that's going to be our x value there. So our h is 3. And our a value, that y value right there, that's a plus k equals negative 1. So our a value, we don't know. Our k is negative 5 over 2. That'll equal negative 1. So we get an a value of 1.5. And if you don't know how we do that really quickly, that's just because when you plug in 0, 1 into the transformation rule of x plus h, ay plus k, you should get 3, comma negative 1. So when x is 0 and you plug it into the function, the transformation rule, you should get 0 plus h should equal positive 3. So rewrite that. 0 plus h equals positive 3. And then when y is 1, you get a times 1, or just a, plus k equals negative 1. So that's how you know that really quickly. You just plug in your 0, 1 into your transformation rule. You end up getting it like this. You solve for your variables that you need to solve for, and that's how you get your h and your a when it comes to exponential growth functions. So we have our a We know what our b is. We have our h and our k. Let's go ahead and write our function. So our function will be g of x will equal our a value of 1.5 times our b value of 2 raised to the x minus h, so x minus 3, plus our k value of negative 5 over 2, so just negative 5 over 2. And that's going to be our function. So let's go on to number 12. Over here we have an exponential decay function. So here, our asymptote, we see that y equals 4. So we know our k is 4. Our first reference point, that comes from 0, 1. And our second reference point, remember that's negative 1, 1 over b. We're going to compare the x values between the two to see which point on the graph goes to which pair over here. Between 0, 1 and negative 1, 1 over b. Negative 1, 1 over b has a smaller x value. Since negative 1, 1 over b has a smaller x value, we're going to pick the x value here with the smaller x value. So in this case, it's negative 4, negative 2. All right? And for 0, 1, 0, 1 has a bigger x value, so that means it's going to go with negative 3, positive 1. So what we're going to do is figure out our transformation rule. So we can actually figure out our a, b, h, and k. So we don't know our h, our a, or our b. But for this first reference point, we know it transforms into negative 3, positive 1. So we have the function, or sorry, we have the point 0, 1. And we put that into x plus h, ay plus k. It's going to give us negative 3, positive 1. Or in other words, when x is 0, and we put that into our transformation rule, so we know 0 plus h should give us the x value of negative 3. Or in other words, h equals negative 3. Next, when our y value equals 1, and we put that into our transformation rule, we should also get 1. So our a times 1 plus k should equal 1. A plus our k value of 4 should equal 1, or a equals negative 3. We really didn't give you much room here, but we're going to work with what we have. So we know our a equals negative 3. All that's left to solve for now is our b value. So our b, we're going to get that from our second transformation points. So we know we have the point negative 1, 1 over b. And we put that into our transformation rule of x plus h, ay plus k. We should get the point negative 4, negative 2. So the only parameter that we're solving for now is our b value. So this x plus h, we don't care. There's nothing in there we need to solve for. We already have our h and our k. So we don't care for that. So we don't have to worry about that. We only care for the y value to solve for our b value. Oh, sorry, we only care for our b value, so we're going to plug in our y. Our y here is 1 over b. So we have a times 1 over b, which is just a over b plus k. So when y is 1 over b, we put that as y into our transformation rule. We're going to get a negative 2 over here. So a over b plus k equals negative 2. We know what our a value is. We said that's negative 3. We don't know our b value. But in our k value, we know is negative 3, as well, or it's positive 4, sorry. That all equals negative 2. So negative 3 over b equals negative 6. We're going to solve for b, multiply by b on both sides. Negative 3 equals negative 6b. Divide by negative 6. Negative 3 divided by negative 6 is a positive 1/2. So our b is 1/2. So this problem is a huge mess. We didn't give you much room. You will have much more room on the test itself. So we have our a, b, h, and k. So that means our g of x will equal our a value of negative 3 times our b value of 1/2, all raised to the x minus our h, which we said was negative 3, so x plus 3, plus our k value of 4. And that right there is our function for number 12. All right. So let's keep on going. We'll go on to number 14. And like I said before, if you want the answer to number 13, you'll have the key on canvas. You can solve, you can compare your answer on the key on canvas. All right, so here, let's go on to number 14. We'll go over that problem for finding the function of a graph with an exponential of e. So our a value here, we don't know yet, but we do know that our asymptote is y equals k. So we know our asymptote, or sorry, we know our k is 4. And also looking at this function, we see we have a point of 2e plus 4. So that's kind of a dead giveaway that our b value is going to be e. And now all that's left to solve for is our h and our a. So we're going to solve this without using our transform points because I don't really like memorizing them, and we don't really need to have them memorized to solve this function. So what we're going to do is we're going to use our two transformation points that we know of, which is 0, 1 and 1e. So comparing these 2 points over here, we can kind of assume that 1e is going to go to 5, 2e plus 4. That's just because it has an e in the y value, so that's kind of a dead giveaway that it's going to be paired with 1, e. And 0, 1 will pair to 4, 6. So let's look at the first one first, 0, 1 to 4, 6. We know we have the point 0, 1, and we put that into our transformation rule of x plus h, ay plus k. That's going to shoot us out the point 4, 6. So when x is 0, and we put that into our transformation rule, we should get 4. So in other words, 0 plus h should equal 4. So h equals 4. So we know our h value, and now all we need to do is solve for our a value. So what we know from here is that our y value is 1. So we plug that into our transformation rule here. When our y is 1, that's our transformation rule. We get a times 1, or just a, plus k should equal our y value there, 6. Our k we know is 4. So you know a plus 4 equals 6. Or a equals positive 2. So now we know our a value, our b, h, and k. We can make our function really easily. So g of x will equal our a value of 2 times our base of e raised to the x minus h. So x minus 4 plus 4. Our domain is negative infinity to positive infinity. That's an integral form. And that's because the base e function is still an exponential function. So it's still going to have a domain of all real numbers in our range. That's going to depend on our a value and our k value. Our a is positive, and we can see on the function that the whole function is above the asymptote. So we know our function of y is greater than our asymptote at 4. So that's number 14. Same thing as before. I'll leave number 15 for you guys to do on your own. Double check all your answers with the key on canvas. This video is getting pretty long. So anyway, guys, hopefully this helped. And for your test, I would study this, everything we went through, finding functions from a graph, being able to graph a transform function, all your properties. So go over the quiz that you took, and hopefully this helped a bit for your test.